So far, we've been looking at how exceptions work within a specific block of code. Let's look now how they work when we call down through multiple methods. Let's say we have a method here, we'll call it method A, and method A does some work. And as we know, whenever we use methods in a computer program, it works with a stack, right? So method A gets a spot on the stack, and it takes up some space on that stack. Let's say method A calls method B. Let's go ahead and wrap up that call to method B in a try-catch block. So now, of course, we're going to have method B's implementation, which does some work. So again, it's going to get a spot on the stack and take up some space there. So then method B calls method C. Method C again does some work, gets a spot on the stack, takes some space. And again, D does the same thing. So let's say now we're down here inside of D, and D does something that throws an exception. Right? So now that exception occurs, and now something has to try to handle that exception. So what happens is the system starts trying to see if it can be handled. Since method D doesn't handle it, it wants to start looking up the call stack to find some code that can actually handle this exception. Well, remember here in method A, we put that try catch in place. Well, that catch puts a marker on the stack. So what happens now is that Java looks up the call stack, and when it finds that marker, it says, oh, you can handle this exception. The call stack is cleaned up, and then control is passed to that catch block. So that means then, of course, is that exceptions propagate up the call stack, meaning that they can actually cross method boundaries. So the question is that how could method A know it had to be responsible to catch an exception that occurred all the way down in method D? Well, in Java, the exceptions that a method throws are actually part of that method's contract, just like its return type would be or the list of parameters it accepts. So in Java, a method is responsible for any checked exceptions that might occur. And it basically has two choices for dealing with them. One is it can catch the exception, but it doesn't have to catch the exception. But if it doesn't catch the exception, then it must document that that exception might occur. The way that's documented is that a method can have a throws clause on it. And that throws clause needs to list any checked exceptions that might occur within that method that it doesn't handle. Let's look at some code and get a sense of how that works. So let's think about our flight class. Let's say we want to add some functionality to our flight class that allows passengers to be added from a text file. So the format of our text file will be that the first thing on each line is the number of people in a given party, a space, and then the name associated with that party. So we'll have our flight class here. Remember, we have our passengers field. I'm going to add a method on here called add passengers. This implementation of add passengers accepts a string parameter, which is the file name to read the passenger information from. So whoever calls this method is going to pass in the name of the file they want us to read the passenger information from. The code we use to deal with this passenger information is going to be very similar to the code we used earlier to total up the numbers from inside of a file. So we're going to need a buffered reader. So we'll go ahead and create an instance of that buffered reader that wraps a file reader that uses the file name that was passed in. We'll need a variable to hold each line that's read in. Then all we have to do is read in each line. Now, since there's two values on each line and we want the number of people in the party, we're going to use the split method on the string to go ahead and get that first field. And then we'll use our integer.valueOf to convert that initial value from a string into an integer and simply add it to our number of passengers. Now we know from the work we did earlier, totaling up values inside of a file, that exceptions can be thrown in this code. Now in this case, we don't want to catch them. We certainly could catch them here, but it probably makes sense that those exceptions propagate up to the caller because that file name came from the caller. So if there's anything wrong with it, they might know what to do with it based on the exception. So rather than catch the exception here, we're going to document that it gets thrown. So on our method declaration here, we're going to add a throws clause, and we're going to say throws IO exception. Now the reason we know that we throw an IO exception is because if we were to look, the file reader constructor is documented to throw to file not found exception, and the buffered reader readline method has a throws that says it throws an IO exception. Now since a file not found exception is also an IO exception, we can simply say throws IO exception. And again, the key thing here is that if we didn't catch it and we didn't put the throws on, the compiler would actually complain that we weren't dealing with the exception. So by saying that we throw it, that's our responsibility in dealing with it. Now we have another thing we have to think about. We processed this file, but we've opened it up. There's nothing to close it. Now we want to make sure that file gets closed whether we succeed or not. But we don't want to actually handle any errors. But we can still use try to make sure the file gets closed. We can wrap this code up in a try and then put the finally afterwards, which closes the file. Now this way, if we go through and process everything and we succeed, then the finally will run and it'll close. Also, if we go and we process things and an exception occurs, the finally will still run, close the file, and then let the exception call up the call stack. Now, since exceptions are part of a method's contract, how does that work when one class overrides a method from another class? Well, when you override a method, the throws clause of the overriding method must be compatible with the throws clause of the method being overridden. So say, for example, we have our cargo flight class that extends flight, and it wants to override that new add passengers method we just put in there. Well, it needs to be compatible with the throws clause of flight's implementation of add passengers. Now, there are three ways to be compatible. One is to simply not throw the exceptions. And so our method as it's written right now with add passengers is considered compatible because we're not generating any exception that wasn't already defined in the base class. Now, we can also have a throws clause that throws the same exception. So if we say on the end here, throws IO exception, that's compatible as well, because it's the same thing that the base class said. But we can also indicate that we throw a derived exception. So for example, file not found exception derives from IO exception, therefore it's okay for us to say throws file not found exception. Right? And the reason this makes sense is because we have to be compatible with our base class, right? Because remember that somewhere there might be code that has a reference to an instance of our cargo flight class, but might be using a variable declared as flight, right? So that code would only know about the capabilities of add passengers as implemented in flight. So any try catch they put in place there, they're going to catch the exceptions that are defined on flight's implementation of add passengers. We want to make sure that our derived class doesn't start throwing exceptions that the user of our class didn't know they were responsible to handle.